Next is the molecular mass of polymer. Molecular mass of the polymer. See, the polymers, the properties of the polymer is closely related to their molar mass. That is the molecular mass. Molar mass, size, and structure. So these are very close to relate molecular mass of the polymer. Okay, size, structure, and molecular mass. Then the growth of the polymer chain. See, the growth of polymer chain during the synthesis is depending upon the availability of the monomer. This is the availability of a monomer based on the reaction mixture. Then the polymer sample contains the polymer chain contains that is varying the length, and hence molecular mass always expressed in average. We cannot determine the accurate mass, just only the average molecular mass only determined. So the mass of the polymer can be determined chemical and physical methods. Okay, so these are the molecular mass of polymer. Then the next is biodegradable polymer. What are biodegradable polymer? See, in nowadays we are using the synthetic polymers. The synthetic polymer means that life is quite long. That means lakhs and lakhs of years that polymers will be decomposed. That's why nowadays that environment problem is very high. So that we are avoiding this, we have to use the biodegradable polymer. Biodegradable means it naturally decomposes. That is in a short time. So these are called the biodegradable polymers. That means the large number of polymers are quite resistant to the environment degradation process, and the responsible for the accumulation of polymeric solid waste material. So that the solid waste cause the acute environment problems and remain the undegraded for quite long time. So that the awareness of the concerned problem created to the polymeric solid waste, so that they create a new one is called a biodegradable system, that is biodegradable polymer. The synthetic polymers have been designed and developed. These polymers contain the functional groups, and the functional group present the biopolymers. That is the aliphatic polyester are one of the important biodegradable polymer. Aliphatic polyester is the main important biodegradable polymer. Some biodegradable polymer like poly beta hydroxybutyrate, co beta hydroxyvalerate. So this is called simply PHBV, poly beta hydroxybutyrate co beta hydroxyvalerate. So this is a biodegradable polymer. This is obtained by the co-polymerization of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. So this is specially used for the packing and orthopedic devices and the control releases drugs. Okay, that PHBV undergoes a bacterial degradation in the environment. So that the preparation we will see 3-hydroxybutanoic acid. The structure like this. That is CH3 CHOH CH2 COOH. So this is 3-hydroxybutanoic acid. 3-hydroxybutanoic acid. And that react with 3-hydroxypentanoic acid. CH2 CHOH CH2 and COOH. So this is 3-hydroxy pentanoic acid. This undergoes a polymerization. There is co-polymerization of this. It undergoes a polymerization reaction to obtain PHBV. The PHBV OCH CH3 CH2 C double bond O CH CH2 CH3 CH2 and C double bond O. So this is called PHBV, poly beta hydroxybutyrate co beta hydroxy valerate. So this is a biodegradable polymer. Then nylon 2, nylon 6. See, this is the alternating polyamide of copolymer of glycine with amino caproic acid. So this is also a biodegradable polymer. The reaction like this. So this is a glycine NH2 NCH2 COOH. So this is glycine. Glycine react with amino caproic acid is NH2, then that CH2 5 times, CH2 5 times COOH. This is the amino caproic acid. So the removal of water molecule. So removal of water molecule from one OH and one hydrogen molecule from this compound. So it will be getting, that is nylon 2, 6. See, the structure will be like this: C double bond O, CH2 NH, then C double bond O, CH2 5 times and NH like this. So this is the amino nylon 2, nylon 6, because glycine having 2 carbon atoms, so that nylon 2, and amino caproic acid having 6 carbon atoms, that is why nylon 6. So the copolymerization of the glycine and amino caproic acid, removal of removal of the water molecule, and it undergoes a polymerization reaction to give nylon 2, nylon 6, that is nylon 2, nylon 6. This is also a biodegradable polymer. Polymers of commercial importance. So polymers of commercial importance, that is it is very commercially important. That means we are using nowadays day-to-day life, we are using this polymers. See, the polymers along with their structure and uses I will give. See, first name of the polymer, polypropene. The name of the polypropene, the monomer is, propene is the monomer, and the structure is like this. The structure of the monomer structure is so this is the polypropene. The monomer is this is name of the polymer, and monomer, and the structure. The uses is manufacturers of ropes, toys, pipes, the fibers like this. So we are using this type of polymer, that is polypropene. Then next is polystyrene. The polystyrene, the monomer is styrene. The structure like this: CH2, CH, C6H5, and entire. Where we use this means that is it acts as an insulator, that is in insulator tape, wrapping material, the manufacturers of toys, radio and television cabinet cables, that is the main monomer, that is the main polymer is polystyrene. Then the PVC, polyvinyl chloride. The polyvinyl chloride, the monomer is main monomer is vinyl chloride. Vinyl chloride, and the structure will be CH2, CH, Cl. Then the uses of this, the manufacturers of raincoats, the handbags, and vinyl flooring, that is the water pipes. So we are using the PVC pipes, that is uses of polyvinyl chloride. Then urea formaldehyde resin. Urea formaldehyde resin. Then so here the urea formaldehyde, so urea formaldehyde resin, so that the monomer is urea and formaldehyde. Then structure like this, that NHCO, NH, CH2, N time. That is for making of unbreakable the cups and laminated seals is used for this polymer. That is urea formaldehyde resin. Then glycol, ethylene glycol and phthalic acid is a monomer. Ethylene glycol and phthalic acid is a monomer, and the structure like this: O, CH2, CH2, OOC, and CO n times. Then usage of this, the paints and the manufacturers of paint, this lacquers and paint industries. Then last one is bakelite. Phenol is the monomer and formaldehyde. Phenol and formaldehyde. The structure like this. I will draw the structure here. OH, CH2, the structure like this. The OH and the CH2. So this usage of this bakelite is making of combs, electrical switches, the handles of utensils and computer disks. Okay, so this is the usage of the polymer and commercial importance of the polymers. Okay, thank you, students.